Next time you're standing on a train platform or watching a locomotive roar across a railroad crossing, take a moment to glance down. Under those long steel rails and the thick wooden ties beneath them, you'll always notice the same thing: stones. Millions upon millions of them. Rough, grey, jagged rocks stretching for miles along the tracks. It doesn't matter whether you're in the United States, the UK, or India, you'll see the exact same setup everywhere. But have you ever stopped to wonder why? Why do modern, high-speed trains run on what looks like nothing more than a bed of loose rocks? Why aren't the rails simply bolted onto a solid concrete surface like a highway? The reason goes far beyond cutting costs. In reality, it's a clever piece of engineering designed to keep trains stable and prevent the tracks from slowly sinking into the ground. And surprisingly, this simple layer of stones also carries a story that links today's railways to the age of old sailing ships. Welcome to Ordinary. Today, we're uncovering the hidden purpose behind those railway stones. To understand why those stones are there, we first need to understand the challenge engineers are dealing with. A fully loaded train is unbelievably heavy. We're talking about millions of pounds of steel, freight, and machinery moving along a single track. If all that weight were placed directly on bare ground, the pressure would quickly compress the soil. The rails would start to sink, shift out of alignment, and eventually bend or buckle, a situation that could easily lead to a derailment. This is where the stones come into play. In railway engineering, these rocks are known as track ballast. The structure of a railway track is actually layered, almost like a carefully built cake. At the very top are the steel rails. Those rails are mounted on horizontal supports called sleepers, or ties. And beneath those sleepers lies the ballast, the thick bed of crushed stone. The ballast acts like a shock-absorbing foundation. Its role is to take the massive, concentrated load of a passing train and distribute that force across a much larger surface area. By spreading out the pressure, it prevents the ground underneath from being compressed or damaged. But here's the really interesting part. Here's something many people don't realize: railway tracks aren't actually anchored deep into the ground. If you take a close look, the rails are essentially resting on top of the stone bed, almost like they're floating. They aren't bolted into the soil underneath. Instead, the system stays stable thanks to friction and the enormous weight of the stones themselves. This slight flexibility is important. When a powerful train rushes over the rails, it creates intense vibrations and forces. Because the track sits on this loose but stable foundation, it can absorb a bit of that movement instead of cracking or snapping under the stress. At this point you might wonder, alright, the stones support the weight, but why these particular rocks? If you ever picked up a piece of railway ballast, you'd notice something immediately: it's not smooth at all. In fact, it's rough, sharp, and pretty unpleasant to hold. Railway tracks never use smooth, rounded pebbles. And there's a very deliberate engineering reason behind that choice. Think about what would happen if you stepped into a pile of marbles or ball bearings. You'd slip and slide in every direction. Smooth stones behave the same way. They roll over each other easily. If train tracks were laid on top of rounded rocks, the constant vibration from passing trains would cause the stones to roll and shift, eventually allowing the rails to move out of position. To prevent this, engineers use crushed stone, typically materials like granite or quartzite, that have been broken into sharp, angular pieces. When these sharp, broken stones are packed tightly together, they behave very differently from smooth rocks. Instead of rolling around, they lock into each other. Their rough edges grip and wedge together, forming a firm, stable base that still allows a small amount of movement. This interlocking structure keeps the rails steady and prevents the track from shifting sideways. So even when a high-speed train races through a curve, the ballast isn't just carrying the load, it's also helping keep the track firmly in place. But supporting the track is only part of the story. These stones also help defend the railway from two of its biggest long-term threats: water and weeds. If train tracks were placed directly on bare soil or even on a solid concrete slab, heavy rain would quickly create serious issues. Soil can turn soft and muddy, and over time it may wash away, leaving sections of the track unsupported. Concrete, on the other hand, tends to trap water on the surface, creating puddles that can accelerate rust and damage the steel rails. A bed of crushed stone solves both problems. The gaps between the rocks allow water to pass straight through, working almost like a giant drainage system, similar to what engineers call a French drain. When rain falls, it quickly filters down through the spaces between the stones and away from the track, helping keep the ground beneath dry and stable. And then there's the issue of weeds. You'll almost never see thick vegetation growing between railway tracks. That's because the deep layer of sharp, crushed rocks makes it extremely hard for plants to take hold. Without proper soil, roots struggle to grow. And if plants did manage to spread there, their roots could loosen the ground and weaken the solid base that keeps the track stable. So those simple-looking stones actually serve several important purposes at once. They support the enormous weight of the train, help drain rainwater away from the track, and make it difficult for weeds and plants to grow. In one system, the ballast works as a foundation, a drainage solution, and a natural barrier against vegetation. But before we wrap up, there's one more interesting detail. Why are these stones called ballast in the first place? The answer comes from the world of sailing. Hundreds of years ago, when wooden ships traveled across the ocean to collect cargo, they often started their journey empty. Without enough weight, the ships would sit too high in the water and become unstable in rough waves. To solve this problem, sailors filled the bottom of the ship's hull with heavy stones to weigh it down. Those stones were known as ballast. Once the ships reached their destination and began loading valuable cargo, the extra stones were no longer needed. So sailors would simply unload them at the port, leaving piles of ballast stones along the shore. When the first railway systems were being built, engineers needed a material that was heavy, durable, and inexpensive to keep the tracks stable. At many ports, they noticed large piles of stones that sailors had dumped from their ships after arriving with cargo. Those stones had once been used as ship ballast, and railway builders quickly realized they were perfect for supporting train tracks. So they started using those same stones beneath the rails, and the name ballast carried over from the sea to the railway. The term stuck, and it's still used by engineers today. So the next time you pass by a railway line and notice those rough grey rocks, remember they're far more than just scattered stones. They form a carefully designed foundation, one that drains water, prevents plant growth, and supports the massive weight of passing trains. It's a simple but brilliant engineering solution that has helped keep railways running smoothly for more than 2 centuries. If you enjoyed exploring this hidden story behind an everyday sight, don't forget to like the video and subscribe for more fascinating histories hiding in plain view. Thanks for watching.